there's epsilon greater than 0, so some value, maybe we can say 1 over 100, right? This is greater than 0 integer, so there's just arbitrary, right, integer, such that s of n, so the sequence minus the limit is less than this 1 over 100, or epsilon. Okay, so basically if we break down what is this complicated definition for epsilon, so I said example, just think of it 1 over 100. That's a good way to think about it. 1 over 100. So the distance between the sequence and the limit, it's like sequence is something like, you know, say 1/2, 1/4, 1/8, 1/16, right? This is 1 over n squared sequence. This is the sequence 1 over n squared. But, you know, the idea is that this is going to go to, what is it going to? It's going to 0, right? This is like one example. So the idea is saying that a sequence in the limit, the sequence is referring to, so sequence, so we give an indice n, and the sequence is the element when it's at n. Okay, so this is n sub, is it s1, so this is sequence s of n. If this is s of n, then this is s of s1, this is s2, this is s3, right? Okay, and this is maybe Sn. Sn is G, okay? S of n is like you're going to the end. Okay, so yes, this is when we say S of n, we're just referring to one element. We're not referring to the entire sequence. We're referring to one element. Okay, S of n is just a number. It's an element in the sequence S of n. So S of n, yes, this is just one number. So it's like going really down, and the limit, right? So this number, right, like as you increase n, it will go closer and closer to the limit, right? The sequence goes on, it will get closer and closer to the limit. That's what it's basically saying. So the sequence s of n minus s, right? This is very small because s of n, it's very, very big. It's like getting bigger than n. Yeah, n bigger than k is just saying that k can be something very big, right? So n bigger than k, and k is just an integer. So, you know, s of n is a number. S of n is a number that is in the sequence and is getting very close to the limit. And I just take absolute value, so it's always positive, and we're going to say it's less than a very small value, 1 over 100. For example, epsilon is 1 over 100, right? So what it's saying is saying that it's eventually becoming like 0. This, right, is eventually becoming like 0. S of n minus s is eventually going to become like 0. It's becoming it's smaller than 1 over 100. So it's very, very small. It becomes smaller and smaller and smaller as we increase n over k. As we increase n over k, right? As n becomes bigger, it becomes closer and closer to the limit. So this is one way to describe the definition of the okay, this is the definition of the limit. So now we want to use this definition to prove this. So we have to prove that this limit equals to this limit. This sequence equals to this limit. Okay, so we're just gonna start with the definition. We're gonna say, so for an epsilon greater than 0, this value, when you write the proof, you're actually not going to know this. You're just going to leave this blank. You're going to fill it out later. You cannot figure this out from the beginning. Just leave it blank. And you know, okay, so you know that there's a k that exists, right, bigger than this. Why? Because Archimedean property, right? Archimedean property, what is that? It just means that there you can find any number, you could find a very big number. That's the Archimedean property. Okay, that eventually you can find any big number. This is k. So we know that. Okay, so how did we get this right here? Okay, so we're gonna say there's a natural number n, so that n is bigger than k. Okay, so now we have our limit. We have s of, this is what this right here, this is s of n minus s. S of n minus s is right here, and what we want to do is we want to show that it's less than epsilon. So for our given epsilon, we want to show that s of n minus s, this is going to be less than epsilon. So this is what we're going to do. We're going to try and play around with this algebraically so we can get it to be less than epsilon. Okay, so we have it right here. So first we're just going to give a common denominator. So we're going to multiply both of this by 7n minus 5. Multiply by 7n minus 5, and we combine the fractions with like denominator. We get this thing right here. And we simplify the top, we get 41. We don't simplify the bottom. We're going to leave the bottom alone. But we simplify the top, and we get 41. okay, and the bottom stays the same. Okay, now what we're going to do is we're going to say that, okay, this value right here, we just rewrote it again. We're going to say that it is less than this. We're going to less than this fraction. What did we change? We made this 5n. So why can we say that this is less than this value right here? Because we made the denominator, what did we do to the denominator? We made the denominator even smaller. And when the denominator of a fraction is smaller, the fraction actually becomes bigger. For example, you can say 1/4 is less than 1/2, right? The denominator is smaller. It's a smaller denominator. So if the denominator is smaller, then the fraction is bigger. So that's what we did here. We just made the numerator is the same. You see 1, 1. The numerator is the same. 41, 41. It doesn't matter, right? If we made this 41, 41 over 2, 41 over 2 is still bigger because the denominator is smaller. So 41, so we made the denominator here, we made it smaller. If we make the denominator smaller, so the fraction is bigger and this inequality is true. So I wrote like there's a natural number n just because n is bigger than 1. Why? Because what I did is I made the denominator smaller. So right now it's 7n minus 5. 7n minus 5, and this is going to be 7n minus 5, or it can be bigger. If n is bigger, then this will be even bigger. But we know that n is a natural number because we said for any n, for all n, we're only looking at natural numbers for this problem. And we said in the beginning, we said for all natural numbers n. So we know that at the very least, it can stay the same. That's why it's less than or equal to. At the very least, it's the same. But it can also be bigger. And if it's bigger, then we have a smaller denominator, right? We have a smaller denominator. 7n is going to be even smaller. This even bigger amount. So that's how we got this inequality. And once we get this inequality, now we say 7n minus 5n, what is that? 2n. 2n. This is just 2n, so we get this fraction right here. And then we combine it, and you say 41 over 14n. And then what we're going to say is, okay, now we have 41. Now we have a very simple fraction. In the beginning, we had something very complicated. Now we have something very simple, and we just have one fraction. That's what we want to do in the limit proof. In the limit proof, what we want to do is we want to take this s of n minus s. It's usually going to be complicated, and we want to make it just one fraction. And in this case, we just made a 41 over 14. In this case, we're going to say 41 over 14 epsilon. And so this is our k value. And 41 over 14 epsilon. And then we just plug it in and we say, okay, you know what? This is going to be less than 41 over 14k because n is bigger than k. N is bigger than k. That means the denominator is bigger, right? If n is bigger than k, means the denominator is bigger, means the fraction is smaller. See, you understand, right? Okay, and then the fraction is smaller, that's why the inequality is 1, right? If we multiply 41 over 14, what happens? It's going to count 41 over 14, right? This is, never mind, you're not multiplying. You're just seeing that, you're going to say that this fraction is less than epsilon. Because so we made sure that k, we're just going to give it the minimum value, right? The minimum value has to be this. It has to be bigger than this. So as long as it's bigger than that, then this is going to hold for epsilon. And altogether we said that this s of n minus s is less than epsilon. This is the final thing, right? This s of n minus, and we prove this. This is how we do the limit proof. Okay, we just want to prove it like this. Main takeaway is we want to kind of take, we want to make it into s of n minus s, and we want to write it in this kind of form.